Once again, you are welcome to our channel Mathematics Catalyst. And in our previous video, we have discussed about the concept of the functions. And there are one function, onto function, injective function, and there are into function, onto functions. And now we are taking some other topic that is called composition of the functions, right? So for the compositions of the functions, uh, what will you do? Suppose fx and gx are the two functions, and we have to use a single function on the basis of those two functions. Then that function is said to be composite function of the given two functions. Suppose we are taking some example for it. Suppose there is a set A and set B and set C. We are taking some daily life example. Suppose A is a set which contains three things like metal, okay, and second one is suppose plastic, and third one is suppose we are taking leather, and fourth one is alloy, right? So these are our input variables for some machine. Suppose there is a machine which we have to use as a function, right? And when these inputs are passing from this machine, then there becomes some outputs which are concerned with the set B, and outputs are, suppose we are making handle, right? We are making the brakes, we are making the seat, and we are making the other parts, miscellaneous parts like engine and everything. And these are our output variables. And after using these output variables, we are again using a machine, right? And these are the input variables for this machine. When we have to put these inputs, handle, brakes, seat, miscellaneous parts, into the second machine, then output will be a scooter or a motorcycle or a car. It means the manufacturing of the car is dependent on these inputs like handle, brakes, seat, miscellaneous parts, etc. And these outputs are dependent on metal, plastic, leather, alloy. So, what does it mean if we want to manufacture a car or a scooter or a motorcycle? Then we need these elements, these inputs: metal, plastic, leather, alloy, and these are the input variables for manufacturing of these things, right? So it means we have to eliminate these two machines. हम इन दोनों मशीन्स को क्या कर देते हैं, हटा देते हैं, और इसकी जगह पर हम एक कंपोजिट मशीन यूज करते हैं. कंपोजिट मशीन का मतलब हम आपसे एक बात कहना चाहते हैं कि आपने क्या लेने हैं, ये इनपुट वेरिएबल्स लेने हैं, and you have to take these input variables and we have to define a function between this input and this output, है ना? So we have to use these inputs and this is the output which are gained by the set A. Means the composition of the machines is given by a single machine, and this single machine will work for this whole process from input to output variable. And बी सेट को हमने क्या कर दिया, यहां से हटा दिया. तो हमने क्या किया, इस पूरे पार्ट को जो हमने बीच में प्रोसेस डिस्कस किया आपसे, इस पूरे के पूरे पार्ट को हम क्या कर देंगे, एक सिंगल मशीन में कन्वर्ट कर देंगे. तो उसको हम क्या बोलते हैं, आपका कंपोजिशन ऑफ द फंक्शंस. ठीक है? तो देयर इज नो नीड टू चेक whether we are getting the handles and brakes, but basically we are getting the car, scooter, and motorcycle by using these all things, right? So that is called composition of the function. And now we are taking this concept as mathematically. And now suppose there is a function f which is defined from set A to B, right? And g is another function which is defined from set B to C. एंड दिस इज इनपुट फॉर एफ. ए सेट जो है दैट इज इनपुट फॉर एफ. मान लीजिए यहां पर हमारे पास एक्स वेरिएबल है, दैट इज इनपुट वेरिएबल, एंड थ्रू एफ वी आर गेटिंग द आउटपुट वेरिएबल वाई, एंड आफ्टर दैट वी आर गेटिंग द आउटपुट z through g function, right? तो इसका मतलब y is dependent on x variable, means y is defined as fx. X is an input variable, y is an output variable, and when g is defined from the set b to c, then we can say z is function of g of y. If y is equals to f of x and z is equals to z of y, then we can replace this y at this place and z becomes g of f of x. What does it mean? It means g of f of x. Means z is output variable which is dependent on the input variable x. Means whenever you substitute x into g of fx, right? G of f function, then we obtain z directly. Directly मतलब हमने क्या किया, इन दोनों फंक्शन को एक साथ लेकर वी आर टेकिंग दीज टू फंक्शन टुगेदर टू गेट द आउटपुट of the set C. ठीक है, तो x is our input variable and z is our output variable. So in this way we can compose the two functions f and g and make a function g of f which is a combination of both the functions, and this concept is called composition of the function. So we can say it is the composition of functions f and g, which is represented by z, and z is our output variable. So we can understand by using these two concepts what is a composition of the mappings or composition of the functions. Now we are taking some example. Suppose we have a example and f is a function, right, which contains 1 2 3 4 and -1 3, and g is another function which contains 2 6 4 -1 and 3 7. Means f is a function which has domain 1 3 -1 and range is 2 4 3, and second function is g which has domain 2 4 3 and range is 6 -1 7, and we are constructing the function g of f. What is the value of g of f? We want to calculate the value of g of f. What will you do? First of all, we take g of f of 1, because in first pair the domain is 1. Whenever you take 1 at this place, g of f of 1, because we have already defined that g of f means g bracket of fx, means you can take g of f of 1 as g within the bracket f of 1. It means what is the value of f of 1? We can see from here, that is 2, and g of 2 becomes 6, because 2 की इमेज क्या है यहाँ पे 6 है, तो g of 2 becomes 6, यानी कि g of f of 1 is 6, means 1 is input and 6 is output, which belonging to our set g of f. means g of f मैपिंग में जो 1 की इमेज होगी वो क्या होगी, हमारी 6 इमेज होगी. And second is we are taking the second one. This is our first one. Now take g of f of 3, because second element is 3 here, so put 3 here, and g of f of 3 we can write it as g of f of 4, because f of 3 is 4 here, the image of 3 is 4 here, put g of 4. And what is the value of g of 4? G of 4 we can see from here, in the g 4 की इमेज क्या है -1, so its value becomes -1. It means 3 and -1 is the another point which belongs to g of f. Now we are coming on the third one. G of f of third element is -1, put -1 here, g of f of -1. So g of f of -1 indicates that this is 3 and g of 3 becomes 7. It means -1 7 is the other element which belongs to g of f. It means there are the three elements which are contained by g of f. So after constructing g of f, we can say this contains first element is 1 6, another element is 3 minus 1, and next element is minus 1 7. Now we can observe this A set is 1 3 minus 1, and here A set is 1 3 minus 1. And here what is the C set? C set is the output of G function, that is 6 minus 1 7, and यहाँ पर भी क्या है 6 minus 1 7. It means it is clear that whenever we define a function f from A to B, and g is another function which is defined from b to c, then z is a function that is g of fx. It is always defined from the set a to c, राइट ए टू सी. तो बीच वाला जो पार्ट है वो हम यहां से क्या कर देते हैं, डिलीट कर देते हैं, और इसकी बजाय एक डायरेक्ट फंक्शन आप लेते हैं जो कि किस पे डिपेंड करता है, एक्स पे डिपेंड करता है. सो द वैल्यू ऑफ z डिपेंडेंट ऑन द एक्स. सो this concept is called the composition of the mapping, and we have discussed an examples also how we can define the values of g of f if we are taking the two functions f and g in this format, right? And second example is, we can also observe that if generalization is there, if fx is a function and gx is another function, both the functions are defined, and we have to calculate g of f or f of g. How we can find the values of g of f and f of g? Now see, suppose we have one more example, that is fx is equals to sine of x and gx is equals to x square. Find out g of fx and f of gx. Find these two values. One is g of fx and another is f of gx, right? And check whether f of g is equals to g of f or not. You have to test it. Now, if fx is equals to, we are taking the solution of the given question. If fx is equals to sine x and gx is the another function which is defined as x square, then what is the value of f of gx? You should write f of gx. What is the value of gx? That is x square. So it is x square. And f of x is sine x. It means whenever you substitute the value of x, any number, suppose you are taking a at the place of x, so we have sine of a as output. So we are taking x square at the place of x. So what will you get? That is sine of x square. It means f of g is a function has value sine of x square, right? And another one is g of f. How we can define g of f? Now g of f of x, that is g of sine x, and g of x is x square, then g of sine x will be sine x whole square. That becomes sine square x. And there is very big difference between sine square x and sine of x square. So g of fx is equals to sine square x, and these two values are totally different. So f of g never equals to g of f. So we are concluding that f of g is not equals to g of f, means the composition of the two functions is not commutative, right? Compositions of the functions two functions are not commutative. तो commutative property जो है वो establish नहीं होती in case of function under the operation of composition, right? Now we are taking three functions. Suppose we are taking three functions f, g, and h, and we have to check the associativity of the functions also. Now again, I am taking these two functions as it is, and I am considering one more function, that is hx. That is hx. Suppose hx is our log x, right? This is log x. When we need to find out the value of f of g of hx in this way. So what will happen? First of all, we define what is the value of g of hx, this bracket. So g of hx is, what is hx? Log x, and g of log x becomes log of x whole square. So g of hx is this, and now f of g of hx shows that f of g of hx, and its value is log of x whole square. So we can find f of log of x square. If fx is equal to sine x, we can replace x with log of x whole square. That becomes sine of log of x whole square. This is the value of f of g of h. And in the second sense, if we calculate this value, what does it mean? First of all, you should define the function f of g, which is in the bracket f of g. So what is the value of f of g? F of g of x, that is f of gx. What is the value of gx? That is x square, substitute it, and f of x is sine x, so f of this becomes sine of x square. Now, f of g of hx, what does it mean? F of g of hx, and what is f of g? That is sine of x square, and sine of x square में आपको x के प्लेस पे क्या यूज करना है? hx यूज करना है. तो ये क्या बन जाएगा? Sine of hx whole square. And what is the value of hx? That is log of x, so it becomes log of x whole square. So we are concluding that again f of g of h is equal to f of g of hx. Means अगर हम f of g पर पहले ऑपरेट करें, फिर h को ऑपरेट करें, या फिर f of g of h ले, मीन्स पहले g और h को ऑपरेट करें, उसके बाद f को ऑपरेट करें, क्योंकि whenever you solve the function, first of all you should solve the brackets. तो f of g then of h, g of h then f of g of h. So both are same. So this composition of mapping is associative in nature. Okay? It is not commutative but associative. So we can say it holds associative property. So after discussing all the things, we have to conclude that there are basically, if two functions are there, then f of g is not equals to g of f. It means composition is not commutative. But whenever you are taking three functions, f, g and h are there, then g of, first of all, find f of g of h, then f of g of h. So both are equal. Means this holds the associativity by the composition of the mapping. So composition of the mapping is not commutative, but it is associated in nature. So in this way, we can apply the composition rule on the simple questions and on the algebraic expressions or any other functions. We can apply these kind of operations. So after this, we will go for some more videos. These are the inverse of the functions and their graphical evidences of the inverse of the function. Please wait in our next video how we can define the inverse of the function with their graphic analysis. And meet you soon in our next video. Thank you.